Okay, in this video we will be talking about more exceptions to the octet rule, but here we are going to talk about expanded octets. And I guess I should say here that expanded octets are far, far more common than those electron deficient compounds. The electron deficient compounds, I gave you a few examples. Just know those examples. Expanded octets, you really need to be able to recognize when you have that situation. Okay, so this is for elements in the third row or lower. They can have 8, 10, or even 12 electrons in a Lewis structure. And you might wonder why that is. Well, it's pretty simple. These are bigger elements, or bigger atoms, I should say. And that gives them more room. Think about a golf ball versus a basketball, just to make it a little extreme. You can fit more stuff around the basketball than you can around the golf ball. Okay. So let's just take a look at that. Anything in that third row or lower. So we're talking about like phosphorus. Now let's just write this down. This is not an exhaustive list. Phosphorus, sulfur, chlorine, arsenic, selenium, bromine, etc. Okay. Third row or lower. So let's look at PCl5. This is a good example. PCl5. Again, going through all the steps, starting at 1, counting electrons. 5 electrons for phosphorus, 5 chlorines with 7 electrons each, and that gives us 40 electrons. Okay. 40 electrons. Which one is in the middle? Well, it should be fairly obvious that the phosphorus is in the middle. 1 bond to each chlorine. And some of you might be saying, well, why don't we just bond 2 chlorines together? Because that's just not how the structure is. Okay. So we have 2, 4, 6, 8, 10 electrons used. So that leaves us with 30 to play with, to place around here, to finish out this structure. And we have 5 chlorines. So 30 divided by 5, 30 over 5 is 6 electrons per chlorine. Okay. So we just put 3 pairs around each chlorine. 2, 4, 6, 2, 4, 6, 4, 6. I guess you don't need to hear me count. Okay, and if we look at this element, or I'm sorry, this structure, the phosphorus, it does not have an octet. It has 10 electrons. Is that okay? Yes, because it is in the third row or higher. All right, so let's just do 2 more examples of that. And let me give you those examples. Xenon tetrafluoride. Okay, so what I want you to do, pause the video, do the Lewis structure for xenon tetrafluoride, see if you can get it, and then of course I will do it. Okay, so you've paused the video, you've given it a shot, hopefully. And really, when I give you that chance, the only person, if you don't do it, the only person you're harming is yourself. So just go ahead and do it. I know it seems kind of silly, but you need the practice, okay? So xenon has 8 electrons, and you might be saying, whoa, xenon is a noble gas. It doesn't normally react. You are absolutely correct. But if you look at the periodic table, it is in the 1, 2, 3, 4, 5th row of the periodic table, big element, it has a fairly, those electrons are fairly far away from the xenon, those valence electrons from the nucleus, I should say, of the xenon, and so we can force it to react. And fluorine being the most electronegative element, it will react with things like fluorine. Okay, and again, we have to force it under laboratory conditions. It's not something that would normally happen. So here we have 36 electrons. Go ahead and do our Lewis structure. Xenon in the middle there. Fluorine, 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 and fluorine. And that is a total of 8 electrons used. So that leaves me with 28 electrons, okay? Now if I fill the octets on the fluorine, let's just see what happens. That's 2, 4, 6, 8, 10, 12, 12, 14, 16, 18, almost forgot how to count, 20, 22, and 24. Okay, so that's 24 of those 28. So 24 electrons, that leaves me with 4 now. Okay, there's only one place they can go, and they go on the xenon in pairs. It doesn't exactly matter where we put them. They just kind of got to go on there somewhere. Okay, so again, xenon now has 12 electrons. If we look at it, and just inside that green circle, there are 12 electrons. 4 bonds with 2 electrons each, that's 8, plus 4 more for the lone pairs, and that gives us 12 electrons. And again, xenon is below the 3rd row, it's in the 5th row, so that's perfectly fine for xenon. All right, I think you get the idea. So once you go ahead and do SF4. Okay, I assume you've done SF4, so we'll go ahead and do it together. Sulfur has 6 electrons, plus 4 for fluorine. It's starting to become a little repetitive, hopefully, and you're starting to get the hang of this. And that gives us 28 plus 6 is 34 electrons. Okay, so do the Lewis structure. Sulfur, fluorine, 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 and another fluorine. That was 8 electrons used, and so that leaves me with 26 electrons. Put them in pairs around the fluorines. Okay, so that was 24 of those 26. That leaves me with 2. Where do they go? They just go on sulfur. Again, it doesn't matter where exactly. Now, this is one of those things you got to get down, because the next step in chapter 11 is to use these Lewis structures to get the shape of the molecule. And the shape of the molecule really determines a lot about its behavior. So you need to be sure that you get these Lewis structures down.